Well, here we are. The hull is done and it's time to work on the superstructure. You're going to learn now that a lot of things aren't done in series. I do a lot of things in parallel. In fact, most of the superstructure is already finished and it was done well before the hull was fiberglassed and painted. In fact, a lot of the superstructure is right here behind me. So let's learn how to make it. The individual decks were laser cut, but they're very thin. So in order to get the right spacing in between them and make it into a three-dimensional shape, I have to cut spacers of the appropriate thickness to space the decks apart. And to complicate matters, each of the decks has a different height. But it's not as easy as simply measuring off the plans and applying that to the model. Remember, the plans are to a scale of 1 to 200 and the ship model to a scale of 1 to 144, so it's quite a bit larger. But there's an easy way to compensate for that. I printed off this ruler in TurboCAD that is scaled to 72% of life size. So when I use the printed ruler to measure 24 millimeters on the plan, I would cut a spacer to give me a real-world spacing of 24 millimeters. Well, it's taking shape, but there's still a long ways to go from this to this. There are two distinct looks to the deck on the Oceanic. There's a green surface that's probably a non-skid type of surface, and other areas of the deck are left natural wood. I'll simulate the non-skid surface with sandpaper. 220 grit seemed to be about right after painting, because the paint fills in the grit a little bit. I'll apply the sandpaper with contact cement and roll it down with a roller to make sure it's nice and tight. And then cut off the sandpaper with a sharp knife. I'm pretty sure I don't really need to prime this because anything will stick to sandpaper, but I'm undercoating everything with the same primer so that there's a nice solid base to put the color coats on. And now that I've brought up color, that's kind of presenting a bit of a problem. I've got lots of photographs of the ship, but every one looks a little bit different than the others, and color is not very consistent. Since the ship doesn't exist anymore, I've got no real reference, so I'm just going to have to use a little bit of artistic license and hope that it looks good. The basic colors other than wood and white are green for the deck, yellow for some of the superstructure parts, red for the lifeboats, and blue for the top of the funnel. I've been using certain kinds of paints for years because I know that they behave well together and they look good on wood. The bin primer is a thick, high-build paint that fills in wood grain very nicely, and it sands to a mirror smooth finish. The Rust-Oleum Gray primer sticks to almost anything, and the Rust-Oleum Painter's Touch is a basic flat white. For colors, I use acrylic craft paint. They cover well, can be brushed or sprayed, and they come in a million colors. The colors don't always look the way they do on the bottle. So I put some samples of different colors that I may want to use on the model onto a sheet of paper and let them dry. Then I pick the colors that I think best represent the colors on the real ship and use them on the model. Now, I usually work in wood, so I put some samples of each of these paints onto some brass and some styrene, and then I tried to scratch it off to make sure that it would stick well. With the primer undercoat, it stuck very well. Before spraying, this stuff has to be thinned with a little bit of water and stirred very well. Then I cut some paint filter netting and put it under the cap of the bottle. Airbrushes are very sensitive to paint lumps, and this helps filter any out. Right about now as I'm painting, I'm starting to think that color doesn't look quite right. And I definitely like this new color much better than the first. The most important part about using an airbrush is keeping it clean. And one nice thing about acrylic paints is they clean up with water. And I usually stuff some paper towel in the bowl to soak up the moisture. The planks appear to be 6 to 8 inches wide, and they have a black caulking in between each plank. I sent samples of different kinds of wood to the client for him to pick one. I was kind of hoping he'd go for cherry because I think it looked the nicest, but he decided on basswood, so that's what it's going to be. These basswood sheets are supposed to be 1/16 of an inch, but they measure out to about 0.06, and in model scale that is about 8 1/4 inches wide, and that's pretty close. This is not a bad time to show you this conversion table that I made in Excel. With it I can easily see the full-size measurements versus the model-sized measurements. So my 8-inch plank would be 0.056 inches or 1.4 millimeters wide. So my 0.06 in actuality is pretty close. Other common measurements like railings and doors are also easy to see. I'm going to glue several sheets of basswood together and try and cut and install 5 planks at a time. I'm using 5 planks because it looks like that's as thick as my table saw can cut. I'm using black spray paint to simulate the caulking in between planks. It doesn't have to be an even coat, in fact a little bit of variation is a good thing. If this doesn't make any sense, just hang on, it's going to in a moment. I glued 5 of the painted sheets together and wrapped them in saran wrap to keep the glue from seeping out on the desk. Then I clamped them overnight, but the next morning the glue still hadn't dried inside the saran wrap. I wiped off any excess glue and then clamped them again, and this is the result. I set the table saw fence for about 1.5 millimeters, and before too long I had a whole bunch of plank slabs. These will be glued down to the subdeck, then sanded, and before too long I'll have a really nice looking deck. I've got the area that I want to plank marked as wood here. It's between the edge of this first deck and the superstructure from the next level. And since this is the last deck that I'm going to plank, I have a whole bunch of offcuts from the previous decks. So I'm going to lay them out and mark them so I know which length of piece goes where. Remember, this edge is going to be cut off and this edge is going to be hidden under superstructure, so it's okay if they're a little rough. Start by laying out the subdeck and any clamps or glue you're going to need, and then lay out the planks in the correct order. Spread some glue on the subdeck, and then apply the planking sections one at a time. Press the plank sections firmly into the glue and tightly towards one another. The edges of these plank sections will curl from the moisture in the glue, so clamp them all down well. And if you're worried about it sticking to the clamps, you can put some saran wrap or a piece of tape down before the clamps. Sanding can sometimes round off the edges of a surface where you want it to be square. So this is a good point to sand this. Before cutting off the edges of the planks, I can sand this, and if it rounds off the edges, I don't care. I'll be cutting them off soon anyway. And pressed against the surface of the cutting mat, it's very easy to use the edge of the plywood to trim off the ends. I use a product called tung oil on the bare wood because it leaves a beautiful protective finish. It's made from the pressed nut of the tung tree. You wipe it on in a thick layer, and then wait 10 minutes and buff it off with a soft cloth. Then after about 24 hours, you can go over it with some steel wool, vacuum off all the steel particles left behind, and reapply. To take up the space where these planks aren't run, I'm going to use some cheap basswood of the appropriate thickness. The glue's moisture can cause the wood to swell and curl, so if I spray water on the top of this, it'll curl back. In this application, it's not important because I'm going to be clamping this down, but it looked like a good place to demonstrate this. I'm not at the stage where I'm going to be permanently attaching decks yet, but I'll talk a little bit about it here. When I've got the walls attached and more of the details filled out on each of these decks, I'll be gluing and mechanically attaching them directly to the hull. I'll be using weights and rubber bands and clamps, alignment pins, and these threaded rods that are screwed directly into the hull. I showed how to make these brass parts in the metalworking video, but now we're going to have to install them. You can see that the window area is etched into the brass a little bit, so this makes it very easy to puddle a little bit of paint in there, and then it just stays within the boundaries of the window. And if you do happen to go outside the lines a little bit, it's very easy to use the end of a chisel or another blade to scrape the fresh paint off. If the paint is dry, you can still do it, but you have to be more careful not to damage the paint underneath. These were pre-curved before painting, so now when I slide them into place, there should be very little tension on the glue. And again, I'll show this in more detail in the metalworking video. I left the deck just a little bit oversized, so when I slide these into place and put some sandpaper in between the deck and the metal, I can sand the deck down and it fits perfectly. This wax paper will keep the parts and the glue from sticking to the deck below. And I want to make sure that the decks are attached tightly, just like it's going to be when it's completed. I'll apply some glue to these large gluing surfaces on both sides. And run a bead of glue around the edge of the top deck. Then I'll press it firmly into the glue and clamp it down. If you can't use a regular clamp such as this portion of the deck with overhangs, I can just use some blocks and rubber bands. Then after that's dry, I'll turn it upside down and wipe some glue into the bottom joint. Then these door wells are filled with some properly cut pieces of styrene. These curved areas at the stern are just continuations of the side railing. I'll bend the tail end of that railing around an appropriate sized dowel and test fit it on the model. If it doesn't fit perfectly, sometimes it's easier to use sandpaper to reshape the wood rather than to rebend the brass. And then when it fits perfectly, it's ready for paint. A lot of the walls on the Oceanic have these round corners. They look really nice, and I'm going to make them out of styrene. I'll take some round styrene tube, cut it into quarters, and glue it onto a flat piece of plastic. Then I'll scrape the seam flush and paint it and apply it with glue. There are a lot of windows on the Oceanic, and I'd like them to look like they're reflecting either sky or sea, so I'm going to paint them a deep blue. The raised edges left by cutting partway through the plastic make it very easy to paint a perfectly shaped window. Those curved areas around the bow are going to be difficult to do, so I'm going to use cardboard to make templates that I can cut pieces out of. Once these shapes are perfected, I'm going to have these parts laser cut out of styrene, including the windows. Once the curved section between the main deck and the third deck was perfected, I've added some sides to it. The front of the ship is going to be covered with two main pieces of plastic. The first one, as you see here, is going to cover most of the front, and then a second piece is going to cover the top section. This is the second curved piece that covers the front of the superstructure. I was careful to make sure that it matched the deck well at the bottom of the curved piece, but I didn't put too much work into the top. That's because I'm going to use tape to define the shape of the top of the curved piece. I'll use this as a template to make another template that will be a little bit more refined. This iteration matches the underside of the bridge wings perfectly, but as you can see, I left the top uncut. It's very easy to cut along the edge of a hard surface and cut the top off of this template. Now I'll mark a line so I know where to cut the second piece so that it can meet the vertical sides of the first piece. And again, I'll check to see how well it fits. Now that I've got the shape roughed out, I have to put these into the computer somehow, but as you can see, they'll never fit on the top of a scanner. So I put the larger piece on a 24 by 12 inch grid and photographed it. So I'll draw a 24 by 12 inch rectangle in TurboCAD and open that image into the program. Now it's not likely to open at exactly the right scale, so I'm going to draw a line the width of the grid and then scale it to equal 24 inches. I can measure that the photograph opened at 34.3 inches, so I have to scale the X and Y by 0.6997. So then I'll move that rectangle on top of the image and look at it carefully to see that it actually scaled properly. Then I'll trace around the perimeter. I'm going to use a heavier line width and a brighter color so it's easier to see. This is probably hard to watch because it's jumping around so much. That's just the way TurboCAD zooms in and out. But I need to zoom into the corners because I have to accurately position my lines. Then I'll delete that photograph in the 12 by 24 inch box, leaving only the outline. Now, the two sides of the ship are not exactly the same. In fact, it's not even the same as it's drawn on the plans. Compare this set of windows on the photograph to the same windows on the drawing. They're different. And this row of 4 portholes is only on the port side of the ship. So I've drawn this tag with an S on it so I know which is the starboard side of the ship. Then I'll carefully position it over the plans and draw and copy all of the windows. And I'll use this picture of the bow of the ship to get the position of the windows on the front. I want to rotate this image so I'm looking straight from the front, so I'm going to draw a line from one corner to another. And right here it shows me the angle of that line. Now I can rotate the drawing by inputting the negative of that angle in this box here. Then I'll copy these windows that I've already drawn and use them to fill out the section towards the bow. My original plan was to have these difficult curved pieces at the front laser cut, but when I sent the files to the laser cutter it didn't quite work as I expected. Apparently styrene is a very bad material for laser cutting. It gives off very toxic fumes and it tends to explode into flame. So I ended up using this computerized blade cutter. It's called a Click and Cut Zing. Both TurboCAD and the Zing software called Make the Cut can use several different types of file formats. So I saved it as an SVG type file in TurboCAD and opened that into Make the Cut. Then I'll make sure that they're exactly scaled the same by measuring in TurboCAD the width of the drawing and then inputting that number into Make the Cut. And you can see that the drawing itself is much larger than the mat that I have to cut it on. So I'm going to have to be a little bit creative to make this work. What I'll do is leave the plastic overhanging the top and the bottom of the mat, and then have the computer cutter cut the difficult sections like the windows, and the extremities that are off the mat I can cut by hand because they're straight lines with square corners. The plastic I'll be cutting gets stuck to this mat, and then that pair goes into the machine. So the next thing to do is set a reference point for the cutter to start, and in this case it's going to be right at the corner of the plastic piece. Now that the machine knows exactly where this corner of the plastic sheet is, it can start cutting. Here you can see the extra plastic hanging over the mat that I'll be cutting by hand later. And a close-up of the cutting head doing its work. It doesn't cut all the way through the plastic, but it doesn't need to, as we'll see in a minute. It cuts a groove with a bit of a raised edge around the perimeter, which comes in handy when painting these windows. I'll cut through this straight line to the inside corner, and then I'll flex the scored line that the cutter made in order to break the part off. Then I'll wrap it around the superstructure of the ship and see how it fits. I can see that I need a little bit more material on the top of this piece here, and a little bit more on this side. So I'll edit this drawing in TurboCAD and then cut another piece and try again. The changes are only a few millimeters here and there, but this piece is important to fit properly, so it's worth doing again. And here are just a few iterations of one of the parts. Some printed out in paper, some in plastic. There would have been more than this, but this is all I could find. And after a few iterations, it fits nicely. I put these clamps on the top so that it stops it from sliding off the top of the superstructure, and I carved hooks in the back of the plastic so that I can put some tension on it while the glue dries. The hooks are just extra material that I can cut off afterwards. Now I'd like to shape this front piece so that it kind of takes the shape of the superstructure before I glue it into place. I'll make a jig that will hold this plastic in the rough shape of the front of the superstructure, then I'm going to heat it and let it cool in this position. I tried a few different techniques to try and heat mold this piece, but I wasn't very successful with air methods. It was just too hard to control the temperature with a hairdryer or heat gun or anything like that. But boiling hot water with its constant temperature and ability to thoroughly soak the part seemed to work very, very well. Now I can paint it off the model without worrying about the paint cracking when I bend it into shape, and when I glue it, there will be very little tension on the glue joints. Before I attach the facade to the front of the superstructure, I want to protect some parts from the glue that's going to inevitably leak out from underneath it. So this waxed paper will protect the deck and the sides of the hull, and I'll cover the entire superstructure facade with tape. Here I'm making a notched trowel that I'm going to use to spread the glue on the superstructure. This is a jig I made years ago for making sailing ship gratings, but it works great for making this tool as well. Now, it's very easy to glue wood to wood and styrene to styrene, but I couldn't find a good reference of what kind of glue to use to glue styrene to wood. So I got a bunch of different glues and did some experimenting. I sanded the plastic to rough up the surface a little bit, and then I tried to pull off the pieces. As you can see, most of them didn't inspire much confidence. The LePage 100% glue was the best of the bunch, but I had also heard about a Loctite product called HY4070. It is very expensive and only has a 5-minute working time, but it seemed just a little bit stronger than the 100% glue. So now I gotta work fast. So by now you've probably noticed the timer in the top right corner and that it's exceeding 5 minutes. But that's okay, everything's perfect, right? Oh, 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 oh. So yeah. 5-minute setup time for that adhesive was way too short. So I made a new wrap for the bow, and here I am ready to start applying it using the longer setting time glue. And inspecting the surface for any bubbles or poorly laminated points, it appears that it stuck very well. I'm pretty sure the shorter setup time glue would have had a much poorer contact. Okay, so this is one of the areas that I was really worried about doing, but after some struggles it seems to have come out pretty good. Then I'll add the second curved piece, and now the wraps are finished. And with that success, I think I'm going to wrap up this video. Now, coming up next, we're going to do some custom photo etched brass, do some soldering, other metal work, and yeah, so come back and we'll see you again.